Okay, as we continue in Chapter 2 for 2.5, it's all about linear functions. And when you have a linear function, the rate of change is a constant. So the rate of change is your slope. So here's a skier going downhill. To calculate that slope, you would do rise over run. So we're going to talk about that formula. So the formula for slope is the change in y over the change in x. So if you have 2 points on a line, you can determine the slope. So this is important to keep in mind. If you start out grabbing the y from the second point, you've got to grab the x from the second point as well in your denominator. So those are the equations for slope. So let's go on. We're going to talk about linear functions on the next page. Okay, so the author goes on to tell us that a linear function is called linear if it can be represented by an equation in this form. So, a couple of things. This is only one form of a line. That is called intercept slope form. It is often depicted this way as well, and then it will be called slope intercept form. Okay, that's only one form of a line. Another form of a line is point slope form, and that is written this way. Notice that you don't have the b, which is the y-intercept, in the second form of a line. So this will come up more a little bit later on, but I thought I would just mention that now, that there are other forms that lines can take. So again, here's the equation for slope that I talked about on the previous slide, and m is the slope, and we're going to identify that as your average rate of change. Okay, the b is the vertical or y-intercept of the function. So if you plugged in 0 into your equation for x, you would get your b value back. So they want us in example 4 to identify the vertical intercept and the slope. So in A, we'll do a couple of these together. If this is your equation, the coefficient to the x is always your slope, and the constant is always your y-intercept. So with that in mind, if you go on to B, here is your y-intercept. It includes the sign, the negative. Here is your slope. For question C, here is your y-intercept, including the slope, including the value of the sign, and here is your slope, including the negative. So negative 4 is the slope. Y-intercept for C is 3.25. For D, 3.25 is your y-intercept, and your slope is negative 4. So therefore, these two equations are exactly the same, as are these two equations. Okay, so just look carefully at what they're giving you, and you can see that because of the commutative nature of addition, you can write these equations different ways. Still the exact same equation. Okay, in example 5, they're asking us to compare equations that represent legal costs. So L of H, so H is your input, represents the legal fees in dollars charged by 4 different law firms, and H represents the number of hours of legal advice. What is the initial fee? So which initial fee is the highest? So to find out the initial fee, that's what you pay before you walk in the door. So the initial fee happens when your hours are 0. So we see that we have 500 here, 800 here, 0 here, and 1,000 here. So the highest one is found in equation L2. Which rate per hour? Okay, that's about the slope. The other was about the y-intercept. So the slope, which slope is the higher or the steepest? And it looks to me like L4 that had no initial fee, that slope is the steepest. So that's going to be for L4 because its slope is 500. if you need 5 hours of legal advice, which legal fee will be the highest? So what are you going to do? You're going to evaluate the legal fees at 5. So I'm going to set this up and then we can do the math. So I'm going to turn this off and do the math, and you should do the math now also, so when we get back together we'll have answers. Okay, here are my values. So it looks to me that if I needed 5 hours of legal advice, the highest would be L3 and the lowest would be L1. Okay, so let's go on to the next practice problem. A residential customer in the Midwest purchases gas from a utility company that charges according to the formula. So notice it's a linear formula. That's your formula, where C of G is the cost in dollars for G 1,000 cubic feet of gas. Okay, so how would you find C0, C5, C10? Okay, so you would just put in a 0 for your X. You would get $11 would be the fee. If you plug in a 5, it's going to be 11 plus 10.5 times 5. If you plug in a 10, it'll be 11 plus 10.50 times 10. Okay, so what is the cost if the customer uses no gas? So that means the gas consumption is 0, the cost is still 11. What is the rate per 1,000 cubic feet charged for using the gas? So you have to look at your units. Since they are in 1,000 cubic feet, the rate is $10.50 per 1,000 cubic feet. How much would it cost if the customer uses 96,000 cubic feet of gas? So what they're asking you is they're saying plug in 96,000 cubic feet. Okay, so that means just plug in 96 and figure out what the cost is. So you should be able to do that given the information in this problem. Okay, in 2.6 we're going to talk about the effect of the Y-intercept on your line. So look at what we have here. We see that we have A, B, and C. So what do you see that's in common? So what I see that's in common is the slope is always going to be 5. Now don't let C fool you. They just changed the order of the components of the equation. It's the same situation with the slope of 5 as in A and B. So notice what's happening. If your y-intercept is greater, your curve will cross that y-intercept at a higher point. When it's smaller, it crosses at a lower point. So you can see that that's what you would expect here. So we'll do this one kind of quickly. So if I say that my slope is 5, and here is a y-intercept of 2, here is one of 4, and here is one of 8. So since it's going to be a positive slope, I'm just going to estimate. This is how those 3 equations would differ. They'd have the same slope, but one would be higher than the other. Okay, and that's what's happening in this example also. So notice what the B does. Notice where the B is. Notice in this one, there is no B value, but there really is. The B value is 0, and that means that's going to go through the origin. The B value is negative here. It's going to cross below the x-axis, where the y's are negative. The B value is positive here. It's going to cross above. But those 3 lines will be parallel to one another because their slope is the same. So the effect of B is to move your equation up and down the y-axis. Okay, on this page we're going to talk about the effect of the slope. So remember, the slope is the coefficient to the x. If the slope is positive, your line is heading this direction. If your slope is negative, it heads this direction. So the slope itself can vary in degrees of positivity and in degrees of negativity. Okay, but the overall effect is that if your slope is positive, you will be heading up through the first quadrant. If your slope is negative, you'll be heading down through the fourth quadrant. Okay, that's the first quadrant, that's the fourth quadrant. So that's the overall effect of the slope, or the M. Okay, now they want us to match the graphs to the equations. So let's start from the bottom. So look at these two equations. For D and F, my y-intercept has to be negative. So where is my y-intercept negative? So let's look and see if we can figure that out. It looks like my y-intercept is negative here, and positive, positive, negative here. Okay, so then the question is, which is which? So it looks to me that the D would be the g of x because its slope is positive 1, whereas the F slope is not as steep. So this would be the I of x. Okay, so now we've taken care of these two. All right, this one's kind of all by its lonesome. So which has a y-intercept that looks like it's about 4? So we'll change colors, and it looks to me like this is that y-intercept. The slope is going down at about the same steepness as I is going up. So this is going to be K. So now we'll change color one more time. And do you see how these three lines all have the same y-intercept, and that y-intercept is 9? So we have three equations. Here, look at the slope is negative 0.4. This slope is less, negative 0.2. This slope is positive 0.125. So A is the positive one, so that's the j of x. Then we have two negative ones, and one is steeper than the other. So which is steeper? So the more negative one is the C, and that looks like that's going to be your f of x. And the less steep one is going to be your h of x. So see if that makes sense to you and your ways of reasoning. And it should help you have a sense of the impact of slope and the impact of the y-intercept. Okay, we touched briefly on the magnitude of M. We talked about the examples on the previous slide. So now let's talk about this some more. So the magnitude, which is the absolute value of M, determines the steepness. So you can be steep in a negative fashion, or you can be steep in a positive fashion. So the larger the absolute value, the steeper it's going to be. Then the sign tells you what direction you are heading. Okay, so this tells you about the absolute value. So now let's look at the three equations we have graphed in 2.23. They all have the exact same intercept. That intercept is 7. Then you have least steep, slope is 1. Little steeper, slope is 3. Most steep with the highest absolute value, slope is 5. Okay, look at the next one. These were all positive in 2.23. 2.24 are all negative. So look at the absolute value. The greater the absolute value, the greater the steepness. So this is the steepest, the in-between, and the least steep. Okay, so be able to compare your slopes and your steepness. Okay, here in example 4, they say finding the steepest slope from equations. So remember, it's the magnitude. So the overall steepest is going to be the one that has a slope of -6. It's steep in a negative direction. Then you're going to have 4 will have the next degree of steepness, but it's steep in a positive direction. Then you'll have -2. that will be not as steep in terms of the absolute magnitude of it as either of those. So it's going to be negative, but not as steeply negative as the -6. So be able to tell the difference between the magnitude and the direction. The negative or positive sign tells you direction, and the absolute value of the number, that's the coefficient to the x, tells you the magnitude, so the degree of steepness. Okay, we have discussed domain and range in Chapter 1. Now they're going to discuss it in terms of lines. So the general linear function y equals b plus mx has a defined domain for the input and range for the output, barring any constraints of this. Okay, the domain can go forever, the range can go forever. A word about the parentheses by infinity symbols. Since you never actually get to infinity, but you just approach it, that is why you never have a bracket when it comes to infinity. Okay, specific examples, however, may place restrictions on the domain and range, such as in section 2.5. So we're getting there when they start restricting our lines. So let's see. Example 1 on the median weight of female infants. Example 3 on the depreciation of computer costs. Okay, so what they're saying is sometimes even if you have a line, you may not be able to include every value because of the nature of the data that you're looking at. So if you're just going to look at domain and range for these lines below, for A, it's just going to be infinity, positive and negative for both domain and range. But now look at C. C is a horizontal line. So look where it is. It's right here, say, between 2 and 3. So this is y equals 2.5. So the domain, there's no limitation to what x values you can have. So for question C, the domain is going to be negative infinity to positive infinity, just like any other line. Because this is a horizontal line, your range is just going to equal 2.5, right? So it's 2.5 in a box, and that's it. It can't go above it. It can't go below it. It can only equal it. All right, so that gives you an idea of how you want to think about your lines. You can't automatically just say, oh, it's a line. The domain and range will both be all real numbers, which is another term for these expressions. If it's a horizontal line or a vertical line, you're going to have to do more thinking about it. Okay, so let's see if we can read a little bit of this summary. So the graph of a linear function. The graph of a linear function is a straight line. Okay, we know that. We know the y-intercept tells us where it crosses the y-axis, and that's denoted by the b. The slope tells us how fast the line is climbing or falling. The larger the magnitude or the absolute value of m, the steeper the graph. If the slope m is positive, the line climbs from left to right. And if m is negative, the line falls from left to right. Okay, so once again, to reinforce that, slope is positive, it rises from left to right. Slope is negative, it falls from left to right. Okay, you always read a graph from left to right, just like you would read words or sentences on a page in English. Okay, so this is a very interesting exercise because you see how all the lines basically look like they have the exact same slope? Well, don't be fooled. Look at the x and y axes. Only in graph B are the x and y axes the same. And that means that the slope is indeed 1. And that's going to be for letter A. Okay, so now y equals 2 times x. So let's see which one that's going to be. So if our slope is 2 over 1, so what you can do is you can start at the origin. Okay, so let's see about that. All right, so what I'm going to do is, since we know we've eliminated graph B, let's label some more x and y values in the other graphs. So here's 1, 2, if this is 15, this must be 5, 10. Okay, so what's the slope? So start at the origin, and you rise up 5, and you go over 1 to get here. So this is slightly below it. So my graph that's going to satisfy that is going to be D. So right here, that will be D. So let's change colors, and let's see if we can figure out the next one. Okay, if this is 10, this must be 5. If this is 6, this must be 2. So start at the origin, which is your Y-intercept, and I'm going to rise up 2 and rise over, looks like about 4-ish, or maybe even 3, maybe 2.5. Yeah, so this could be this, right? So this is going to be your C. And we'll change colors one more time. And let's see if this is a 6. Then this must be 2, 4, 6. If that's 15, this must be 5, 10. So if we start here, and if we're going to go, let's see, we're going to go up 5 and over about, well, let's see, if we go up 4 over 2. So what are we seeing here? It looks like I am going up twice as much as I am going over. So that's going to be B. So this is going to be B. And I figured that out by starting at the origin, and we can do this one as well for graph B. Let me change our color. So look what's happening here. This is 1, 2, 3, 1, 2, 3. From the origin, I rise up 1, over 1 to get to the next point. So this slope has to be 1, and that's why it was y equals x. Okay, so you can use your slope in terms of rise over run to get the next point on your graph. And then once you have your slope, you can look at the equations they've given you and match the correct one. Okay, so I tried to match up the graphs in A, B, and C to the grids below. So I have that graph B matches equation A, and I have that graph D matches equation C, but I have no match there. So then I tried to go ahead and figure out what these equations are. So see if you match up with what I have. And again, some of them I have to just approximate. Okay, so here is an exercise in constructing graphs and equations of linear functions. So there's many different strategies to finding these equations. So let's go through some of these. Example 1. A forestry study measured the diameter of the trunk of a red oak tree over 5 years. The scientists created a linear model where, so let's see, it's d of y equals 1 plus 0.13 years. So that means that the diameter is on the y-axis, and the y, which is years, is on the horizon axis, or that's equivalent to saying that it's a dependent variable. So, excuse me, y is independent, d is dependent. Okay, so what do the numbers 1 and 0.13 represent in this context? So 1 is that at time, or year 0, I guess, we're going to start measuring, and the diameter of the trunk is 1, and what is it? 1 inch at that point. So at year 0, when we're starting our measurements, the tree trunk has a diameter of 1 inch. Okay, so then as time goes on, it increases, but at a pretty slow rate. So this is telling you that it's going to increase by 0.13 every year. So without putting, doing a 5 years, it's going to be pretty flat curve. Okay, so that gives you an idea of what that should look like without putting the numbers on there. Okay, then, the top speed of a snowplow can travel on dry pavement. That top speed is 40 miles per hour, which decreases by 0.8 miles per hour with each inch of snow on the highway. So it looks like we have speed and we have inches. So if the top speed is 40 miles an hour, and that's going to decrease, it's going to look like this, with this being 40. Okay, construct an equation describing the relationship between the snowplow speed and snow depth. Okay, so speed equals 40 minus 0.8x. Determine a reasonable domain and a corresponding range. Okay, so let's see. What's reasonable for the domain? So let's go from, I don't know. Let's say we'll start at 0. So remember the domain is the snow. And we'll say it's in, with each inch. So it's in inches. So I don't know what's reasonable for inches. Maybe 30 inches will be like the most we'll really consider. So let's say that our domain is something like that. And what's our range going to be? Well, what's reasonable, they told us the fastest it can be is 40, and it certainly can't go negatively. So let's say it's 40 to 0, but you would not write it like that, right? You would always go from low to high. So those would be reasonable domain and ranges, okay? You're not going to present it like this, but rather like that. Okay, so example 3, given a point off the y-axis and the slope. Given a point, 2, 3, and a slope of m equals -5/4, describe at least 2 ways you could find a second point to plot a line. Okay, so I have one way. What if we said, okay, this point is 2, 3. So this is 2, 3, right here. And if the slope is -5/4, then I would go down 5. So 1, 2, 3, 4, 5, and over 4. 1, 2, 3, 4. And that would get me a second point. Okay, what's the other way you can do it? Well, if you want to use point-slope form, you could find the y-intercept by just changing the formula, or you can say my equation is going to be y equals, wait here, let me not do that. Let me back up a sec. Okay, my equation in point-slope form is going to be y minus 3 equals -5/4 times x minus 2. So now you can multiply that out and get a y equals equation. That y equals equation will give you the slope and the y-intercept. That y-intercept is a second point. Okay, in addition, if you write it in function notation, you can put this in your graphing calculator and look at the table, which is in effect a t-table, and get as many points as you want. So once you have a point and a slope, the sky's the limit with what you can do with your equation. Okay, so given this general description, can you figure out graphs? So look what we have. For A, this indicates a linear increase in number of smokers over time. So see, your line is increasing, your slope is a positive number. A linear decrease means that your slope has to be a negative number and it has to be a line. A concave down decrease. Remember, concave down means you're no longer a line. So you're going concave down and you're decreasing. So over time, the numbers go down. That would be C. And then D, a concave up increase. that would be my graph for D. Notice C and D are not lines. A and B are lines, and you do not speak about concavity when you speak about lines. Okay, so this is kind of fun to find the equation given a graph. So it says find the equation of the linear function below, so for 2.30. So here's your equation of a line, y equals b plus mx. So can you find the y-intercept? And you can say yes, it's there. Now look at the scale so you can determine what that is. Okay, so that y-intercept, 1, 2, 3, 4, is -1. So far I have a -1. Now look what you can do. Remember that slope is rise over run. Okay? It's easier to think of that when it is positive. But from the y-intercept, instead of rising up, if I have to rise down, that's going negative. So I'm going down 1. Okay, so that's going to be a -1. So I go down 1, and then I go over 1, 2, 3 to get back on the graph. So that's 1/3 x. So my equation is y equals -1, that's your y-intercept, minus 1/3 x. So my slope has a magnitude of 1/3, and it's going in a negative direction. Okay, so instead of doing rise over run, when I have a negative, I do fall over run, and I always run to the right. Okay, hopefully that makes sense and didn't confuse you. Your other option is to find that point, and this point right here that I'm identifying as my second point is at 1, 2, 1, 2, 3. It's at 2, 3. And you can figure out how to do your subtraction and get your slope, because your original y-intercept was at 0, -1. So what's my slope? Change in y over change in x. And so you can say, let's see if this is going to work out. Well, let me just, oh, I'm sorry, am I doing this incorrectly? I am. 1, 2, 3, 2. So let me erase that, and let's see if we can get the right point. Okay, so it's 1, 2, 3, 1, 2. 3, -2. That's the correct point. So, change in y over change in x. -2 minus a -1 is a +1 over 3 minus 0, and that ends up being -1/3, which is my slope, which I figured out by doing fall over run for a negative. Okay, so in this problem, they're asking us to create an equation and to do that in a sequential ABC fashion. So let's see, the pediatric growth chart suggests linear relationships. You have a line. Lines have slopes and y-intercepts between age in years and median height in inches. So for children between 2 and 12, 2-year-olds have a median height of 35, and 12-year-olds have a median height of 60. Generate the average rate of change with respect to age. Be sure to include units. Okay, so interpret your results. So the average rate of change would be, here's my slope. To interpret it, it would be 2.5 inches per year, and that's of median height. So that's how I would interpret it. Generate an equation to describe the height as a function of age. What's the appropriate domain? What's the appropriate range? Okay, so you're only going between 2 and 12. So therefore, that means that your y-intercept will be 2. So my equation is going to be y equals 2 plus 2.5 times x. Y is the height, x is the years. Okay, so in terms of domain, since you are only going you're starting at time, well, we'll say that's time 0. Yeah, we can say that that's, no, we'll say that's 2. Okay, so we're going to start your function at 2. So let me redraw this, because I'm not going to have it like that. I'm going to have a function that will start, even though time starts at 0, it'll start at 2 with a closed dot, and then it's going to go up. Okay, but it's going to stop at 12, and my cursor has died, so I'm using my finger, so it's not as clear. So my domain is going to be from 2 to 12 inclusive. Okay, that's my domain. Those are the years in question. My range, and I'll put that up here. So my range, it starts at what height? Well, it's going to start at 35, and it's going to equal 35, and it's going to go up to 60. So that's my range. So notice, even though I have a line, my domain and my range is not all real numbers, because we have to think about the content of our problem. Okay, so generate an equation, we've done that. What would this model predict as the median height of an 8-year-old? So what you would do is you would put 8 in for x, and so if I said 2.5 times 8, that gives me 20, plus 2 more inches, 22. So the median height of an 8-year-old, given this model, would be 22 inches. Okay, so that's how you handle example number 6. Okay, in example 7 here it says, given a table, can we work on getting an equation? So determine if the data represents a linear relationship. So that means that x and y have to change in the same proportion, in a constant proportion. Okay, so the rate of change has to be the same. So if this goes up by 2, this is going to go up by 0.047. This is going up by 2. This is also 0.047. Okay, this goes up by 4, and this does indeed go up by 2 times 0.047. So I can say yes, that this is a linear relationship. Okay, determine the corresponding equation. Okay, so since it's blood alcohol, these are number of drinks, and this is blood alcohol levels. Okay, so if I have 0 drinks, it's going to be 0 blood alcohol. Okay, so it does start at the origin, so therefore the blood alcohol is going to have a 0 B plus, and then divide 0.047 divided by 2, because it's this over 2. So you could say that the slope is 0.0255x, and you can prove a linear relationship. Okay, let's go on to example 8 Next. Okay, in example 8, they say, using the point-slope formula to find the equation in y equals mx plus b format. So first thing, in terms of definition, this is point-slope. Okay, so you plug in the point given and the slope given. So here's the point 2, 3. So that's going to be y minus 3. And this is going to be x minus 2. The slope is 5. Okay, so that's the line in point-slope form. Now can you change that into y equals mx plus b form or slope-intercept form? So the first thing I'm going to do is add 3 to both sides. And so I have y equals 5 times x minus 2 plus 3. Distribute that 5x minus 10 plus 3, and combine like terms. 5x minus 7, and there we are with the desired form. Okay, so let's work on some practice problems. So we have, let's see, we have y minus, the y value is 1, equals, and the slope we were given is 4 times x plus 2. Do you see why it's plus 2? Okay, so that's going to be y equals 1 plus 4x plus 8. So y equals 4x plus 9 is my equation. Okay, so I'm just going to set up these other ones, and then you can do them at your leisure. Y minus 5 equals negative 2/3 x minus 3. Y minus 3 equals negative 10 x plus 1. Y minus 4.5 equals 2 times x minus 1.2. So work on those. I've given you it set up in point-slope form. Use your algebra skills to convert the form to Y-intercept form. Okay, we're going to try a couple of these. They want us to change the form to slope-intercept form. So the first thing I would do is move my y. So I have 2x minus 6 equals negative 3y. I would divide everything by negative 3. And so what am I going to get? And I'm just going to do this one over here. I would get, let's see, y equals, okay, so I'm changing the order, negative 2/3 x, and then a minus over a minus will give me a plus 2. Okay, so that's what I'm getting there. So why don't I erase this work since you've seen it and see if you can get y equals negative 2/3 x plus 2 for your answer. Okay, and I'll erase this. Okay, so let's, well, the other one's very similar to it. Well, let's do it anyway, because that's kind of a fun one too. So let me change color so you have a little variation. Okay, so how about if I said 2y equals 3x? Interesting. Okay, so there's no b here. Divide both sides by 2, and you end up with y equals 3/2 x. The y-intercept is 0. It goes through the origin. Okay, so we'll change again, and we'll say, let's see, I have 2y equals 6 minus 3x. Divide everything by 2, and I end up with y equals 3 minus 3/2 x. Okay, here's another one that's going to go through the origin. I have that. Divide by 6, divide by 6. You would also reduce, since 3 goes into the numerator and the denominator evenly, and you can see that these two were the exact same line. Okay, how about this one? So you have some options here. what you could do is multiply both sides by 6. If I did that, I would get 6 divided by 3 is 2x plus 3y equals 36. And that would get me 3y equals 36 minus 2x, divide by 3, divide by 3, divide by 3, y equals 12 minus 2/3 x. Okay, let's do the same thing to the next one. I multiply everything by 6 first. That's going to give me 3x minus 4y equals -1. So 3x plus 1 equals 4y. Divide by 4, divide by 4. Y equals 3/4 x plus 1/4 is my final answer there. Okay, so you should be comfortable going back and forth with these. Okay, we have 3 different topics left under special cases, so let's do those next. Okay, when you have direct proportionality, that is code for saying that you do not have a B. Okay, so there's no B, no Y-intercept. So we give you examples of positive increasing proportionality and negative decreasing proportionality. Okay, so if we have this equation, that's an example of proportionality. So we can say that A and D are directly proportional. So what is the slope? How are things changing? So change in A over change in D equals 5.2. So for every 1 unit increase in D, A changes faster by 5.2. Okay, so that's a direct proportionality relationship. So you're going to have, your slope is not going to be 0, but your y-intercept is going to be 0. Okay, and here's that explanation right here. Okay, slope is not 0. The y is directly proportional, so therefore the b is 0 because it goes through the origin. Okay, horizontal lines are important to recognize. Your horizon is that. So your horizontal lines will always be in the form of y equals some constant. The slope, you would never say there's no slope. You would say the slope is 0. Okay, the slope is 0. So slope, remember, is change in y over change in x. So x changes, but y does not. So 0 over a number is 0. Don't say there's no slope. Say the slope is 0. Okay, so, and this is a little bit more information about that. You can construct a table with that, and what you're going to see is that your y values will always be the same. Your x values will always be changing. So you should check to make sure that makes sense to you on your graphing calculator. You can put, for example, y equals 5 in your graphing calculator. Your table will look like this. You'll have 5 all the way down, regardless of what number your x assumes. Okay, then when we talk about a vertical line, your vertical line, if this is your grid, is going to look like, whoops, sorry, let me get rid of that. Your vertical line changing color will look like that. So your vertical line will always be an x equals. And in terms of the slope, you would say the slope is undefined. And why is that? Slope is change in y over change in x. Because x is 0 and y is some number, a number over 0 is undefined. Okay, so in terms of how that would look, if you were to build a table of that, and you would see that you'd have your x and your y. In this situation, your x would be all the same and your y would be changing. Notice that that is not a function, that is just a relationship. Okay? Okay, so in terms of what does an equation look like, here's your summary. Here's your horizontal line, and your horizontal line is going to that's your grid. Your line would be the same as the horizon. Here's your format, y equals b, y equals the y-intercept. Your slope is 0. Vertical line, this is your grid. Your vertical line would be here. It's an x equal line, and your slope is undefined. And there's no b. It's never going to cross the horizontal. Well, the only time you're going to have a b, I guess, is if x equals 0, and then your b will always be 0. Okay, so this is not a function. Not a function. And this is a function. Okay, so be able to tell the difference between those two types of important lines. Okay, then we're going to go through parallel and perpendicular lines and their relationships. Okay, parallel lines are your train tracks. They have the exact same slope. Then look at perpendicular lines. Perpendicular lines, their slopes are negative reciprocals of one another. So if this slope is negative 2, so if that slope is negative 2, the other slope will be the negative reciprocal. So negative negative 2 is a positive, and the reciprocal is flip it over. So that other slope is going to be 1/2. Okay, so negative reciprocals. You need to be able to create perpendicular lines. Negative reciprocals, important terminology. And think of it this way. Since negative reciprocal has 2 words, you do 2 things to change your slope. First, you negate it. If it was positive, the perpendicular of it will be negative. If it was negative, the perpendicular of it will be positive. And then the second thing you do to it is make it a reciprocal. Flip over the fraction. Remember, you can turn any whole number into a fraction. If your slope had been negative 4, that's really negative 4 over 1. The slope of the line perpendicular to that slope will be positive, because negative of a negative is a positive, positive 1/4. Okay, be able to do that. Okay, on this page, they further define parallel and perpendicular lines, and they give you a chance to practice. So the pink is parallel. So A, those lines are parallel. They have the same slope. B and C are neither. D, I needed to rewrite this other equation. When I rewrote it, I see that the slopes are negative reciprocals, and therefore D is perpendicular. Okay, for these practice problems, I picked out some from the textbook. So practice problem number 3, in the accompanied table, y is directly proportional to x. So find the formula relating x and y. So all we're looking for is the slope, right? So to get the slope, change in y over change in x. Number of CDs purchased is your x. So that's going to be 4 minus 3, which is 1. And then 56.92 minus 42.69. Do that math. Okay, so you should get 14.23 is your slope. So what does that mean? Interpret the coefficient of x in this situation. So that coefficient means that when you purchase one additional CD, it costs you $14.23 more. So that means that you can figure out a proportionality. So you have y, which is your cost, equals 14.23x. So to get this 5 value, plug in a 5 here and solve for your y. Okay, question 13. For each of the given points, write equations for 3 lines that all pass through the point, so that one of the 3 lines is horizontal, 1 is vertical, and 1 has a slope of 2. Okay, so that's kind of neat. So here's a point. So your x and your y are 1 and negative 4 respectively. If you want a vertical line, well, we'll do horizontal first. Horizontal will be y equals -4. Vertical will be x equals 1. And one that has a slope of 2, you can put it in point slope form and say y plus 4 equals 2 times x minus 1, and you should be able to do another one with 2 and 0. 2 and 0, that's a nice one because they're easy numbers to work with. So that's A. See if you can do B on your own. Okay, I put this equation in here, or this problem in here, because I wanted to be able to say a word about standard form. Okay, so this is called standard form. Notice that, whoops, in standard form, your x and y's are on the same side. It's just another form of a line. Solve for y so as to rewrite the equation in the form y equals mx plus b. Okay, so if you have standard form, and you're going to rewrite that, this is what you're going to do. by equals c minus ax, divide everything by b, and I mean everything. So y will equal c over b minus a over b times x. This is your slope. This is your y-intercept. Okay? So what is the slope of any line parallel to that? So any line parallel to it will have the exact same slope, and that same slope will be negative a over b. What is the slope of any line perpendicular? Well, you're going to have to do two things, right? Negate it, so it's going to be positive, and then flip it over, positive b over a. So I liked this problem because it introduced another form of a line, and it gave you another opportunity to use your algebra to convert that form to y equals mx plus b form. So that ends this video.